Welcome to the world of science and technology. As you know that any atom is composed of three fundamental particles, three types of fundamental particles such as electrons, protons and neutrons. But the question is whether neutron is really a fundamental particle, means whether the neutron is really an elementary particle. Because in the early 20th century, scientists were puzzled by conducting such experiments. Means after observing the results of the experiments, the scientists were puzzled. Because up to that time, a neutron was known to be a fundamental or elementary particle. And it was electrically neutral. You know that electron carries a negative charge and proton carries a positive charge, but a neutron was known to be neutral, means electrically neutral particle. But their experiment showed the result that no, if neutrons are really neutral, then how they are showing magnetic moments. That means there is some substructure present within neutrons, not neutrinos, it's neutron, okay? Means substructure is present. That means neutrons are not elementary particle. Otherwise, how they are showing magnetic moments? They are showing magnetic moments. That means some charged particles are there within the neutrons. So this is the concept behind this. And for this they were puzzled because up to that time it was known to them that neutrons are neutral particles. Okay. Later development of Quark model was there. Okay. In the world of physics, you know, Quark model is there. And according to Quark model, means Quark model explained that neutrons are composed of three quarks. Out of three quarks, two are down quarks, and each of them carries a charge of -1/3. And there is one down quark. Two up quarks are there, and two up quarks and only one down quark. Total three quarks. Okay. And the down quark carries a charge of +2/3. Then what is the total charge? -1/3, -1/3, +2/3, that is 0. So the sum becomes 0, means the total charge becomes 0. And that's why neutrons are known as a neutral particle. Okay, but their substructure has three quarks and all are charged particles. Okay, -1/3, -1/3 and +2/3. The configuration is denoted by UUD, small u, small d, means up, up and down. Okay, so this is one thing. So this thing we got to know by the use of or by the help of Quark model. Later one experiment was done known as a deep inelastic scattering. And according to that experiment, it was confirmed that neutrons are really composed of three quarks. One more thing, during experiment the scientists got the value of magnetic moments. And according to Quark model, charges were known to be -1/3, -1/3 and +2/3. So mathematical calculations means magnetic moment according to the mathematical calculations and magnetic moment according to the experiment closely matched with each other. Okay, so these are what? These are nothing but the confirmations. And this experiment, I was talking about one experiment known as a deep inelastic scattering. This experiment confirmed that yes, neutrons are really composed of three quarks. Then standard model is there, you know, strong force, which is responsible for quarks and gluons. Those are bound together by strong nuclear force, and using that theory also we can easily explain the substructure of neutrons. Okay, so this is known as, this topic is known as not known as this topic is actually the topic of discussion is actually neutrons hidden world. So magnetic moments are present, and these magnetic moments are due to the presence of quarks, which are actually charged particles. Okay. So, and one more thing, quarks do not remain static inside the within the neutrons. They are always in motion. Spins are there. So intrinsic spins are there. Again, movement means motion is there. So due to which magnetic moments are there. Okay. Cause behind the magnetic moments are those motions and spin present in the quarks within the neutrons. Okay. Anyway, I am not going to show you the mathematical analysis of this thing, just a logical explanation how scientists came to know that neutron is not actually an elementary particle. Though in school level classes it is taught that neutrons are fundamental or elementary particle, but in higher physics you will know that no, neutrons are not elementary particles. Even protons are not elementary particles. You know this thing. Protons are also composed of quarks. And when a neutron, if there is a transformation of neutron, means you know that a neutron transforms into a proton. So what is the product? Product is known to you. Okay, antineutrino particle is there. Electron is there. Again, that beta decay phenomenon that can also be explained by the help of this Quark model. Okay. Anyway, so means I was talking about the transformation when a neutron transforms into one neutron transforms into one proton. In that case, product is what actually? One proton is there, one electron is there, one antineutrino is there. So I think now everything is known to you. So what? So this is the end of this video. Okay. Okay. So thank you everyone for watching this video.